Hi, welcome to the Year 9 Options video. As you can see, we offer all our Key Stage 4 and 5 courses from the OCR exam board. At GCSE level, we offer the GCSE in Computer Science and the OCR National in Creative iMedia. There is a natural progression from the GCSE up to A level at Key Stage 5 that we also offer at Budehaven. Okay. The OCR GCSE in Computer Science is both the most popular and the longest running GCSE specification in this country. As a result, the course content is the most stable, and there is a large teaching community which provides support for teachers and subject leaders. As I'm the sole teacher of computer science at Budehaven, this is really useful for me. The course develops an understanding of how computers work, how they interpret and manipulate text, numbers, sound and images together in the form of videos, through the use of binary signals, and how they communicate across and between different networks. There is a large programming element where we learn to write program code to solve a range of different problems, learning about software development conventions and practice, how to refine and debug code. Now, in the exam papers are written using a programming language called OCR Exam Reference Language, which is very similar to Python. So that is why we've been teaching Python at school, and we continue to do so through the GCSE. It just makes interpreting and understanding the exam paper a lot easier, while at the same time giving us a programming language that we can use and test in class or at home. The impact of computers in the real world is also addressed, considering societal, environmental and ethical considerations, as well as looking at how software is developed in industry, and there's a significant unit of work on cybersecurity threats and countermeasures, how to stop them. Okay. In terms of how we assess the course, at the end of the course there are two 90-minute written exams. That's pretty standard for most of your GCSEs, and each exam is worth 50% of your final grade. The first exam paper is called Computer Systems, where you look at computer architecture, how the CPUs are built, how the performance of CPUs, different computers can vary. We look at networking, we look at environmental, legal, cultural issues, and in the second exam, computational thinking, algorithms and programming, that's the programming paper where we look at how data is represented on computers and how people write code to get computers to solve our problems. There's a lot of assessment. We do a lot of work on the computers during the lesson, obviously. We do smart quiz where we have multiple choice questions available, and there's a bank of questions for every point of the specification. So each time we introduce a unit, I unlock all of the questions. So when we're using Smart Quiz, you can test yourself on anything we're doing now and anything we've done before. So we've kind of got an ongoing interleaving and revision system in place. We have a 20-minute written topic test at the end of each unit of work, which is typically 2 or 3 weeks, something like that. We have knowledge organisers that I've made, where there are little high frequency, low stakes timed quizzes where you try and answer the questions on the knowledge organisers. People find those incredibly challenging to start with, but once you're able to answer all the questions within the 6-minute time, it means you genuinely know all of that, and then you've got that knowledge at your fingertips for the exam. I've made Quizlet card sets again for every topic on the specification, and I've made little Quizlet and Blookit games that we will use in class or as revision tools. There's also exam practice in the form of past exam questions on paper, or a thing called Smart Advance, which is very clever, where it's an on-screen platform where you get a past exam question, you write your own answer, and then instead of it marking your work and giving you a grade, you then mark the work yourself, and it gives you little check boxes to tick, and through working through that you will develop a familiarity with the mark scheme and then be able to maximize your marks. Okay, we use a flipped classroom teaching methodology in computer science, which means quite a lot of homework. although the homework typically means watching one or more short YouTube videos. What this means, the flipped classroom approach, is that the new content for the lesson you look at before the lesson. So if you need to watch the video once or twice or 3 times, or pause it or rewind or look up one of the words, then you can. And then when you come to the lesson, you've got a basic understanding of the content, so we can go straight into doing some more active work and active learning with that information. Okay, each lesson will start with a little quiz in some form, or a little research task or a revision activity. There'll be some element of class discussion where we can unpick any misconceptions or anything you haven't understood, and then you'll build up a workbook, which is actually a kind of like an empty PowerPoint presentation with little activities in there to do that cover all of the different topics. We do that instead of an exercise book, and that forms the body of your revision notes for later. Okay, we do a significant programming skills course in year 10, and thereafter there are little programming skills and challenges dripped into most lessons thereafter. Okay. Almost all the activities we do on screen. I use Microsoft Teams and a class OneNote extensively, so any resources that we use in class you can access on your phone, on your tablet, from any internet enabled device, which is great for revision. It also means you've got no excuses. If you're absent, you've still got full access to all of the resources and everything we did in class. Okay. I run lunchtime and after school clubs that you're welcome to attend at any time that you like for extra support or catch up, or potentially intervention if there's something where you're struggling. Okay. Post 16, so after year 11, the problem solving and thinking skills and discipline required to be successful in computer science are really transferable to all walks of life, both in and outside of the tech industry. Okay. If you enjoy computer science, it does set you up for further study at A-level, which we're running here at Butehaven, and the A-level in computer science is the gold standard for software development and a route into to university. However, if you're interested in more sort of hands-on things like network or tech support, more creative things like web development or CGI graphics, possibly AI or robotics, there are more specialised courses or apprenticeships you could do at other places. And actually the GCSE in computer science would set you up for all of those. Okay. As part of your year 9 curriculum, we will have taster sessions in both option subjects. I'm personally delivering a computer science taster for each of the year 9 classes, and we'll do a few little swaps. So Mr. Ball will teach a creative iMedia taster lesson. Any questions you have about computer science or about creative iMedia, or you'd like any guidance, drop me an email, send me a message on class charts, or come and find me any lunchtime. One bit of advice that is a good idea for any subject you're considering is ask to have a look at an exam paper. Have a look through, and if you see the questions, it's not whether you can answer them now, but if you see the questions and you think I would like to be able to answer these questions, then maybe that's a subject you should consider. Okay, thanks very much. Cheers now.